Deep breath, good posture, the lights are bright. Okay. Hi everyone, my name is Killian McCoy and I'm a program manager at, I'm a program manager at Hi everyone, my name is Killian and I'm a program manager at Microsoft who's focusing on teaching developers how to make the most out of the Microsoft 365 platform using artificial intelligence. Artificial intelligence has a huge and popular subcategory called machine learning, and today we have Roseanne from the Windows AI platform team here to talk about Windows machine learning and how it starts to solve problems that other AI solutions do not currently. So thank you so much for joining us, Roseanne.
Awesome, thank you so much for having me, Killian.
Yeah, so before we jump into Windows machine learning specifically, Roseanne, can you talk to us about what kind of problems does machine learning solve?
Absolutely. Machine learning is a set of techniques and algorithms that help you where sometimes like traditional procedural programming might not solve your problems. So machine learning usually operates over like historical previous data and it tries to build knowledge based off that data that it has seen in the past so that it can make predictions for new data that it hasn't seen before.
Awesome. And so how does Windows machine learning start to enter this problem space, and what are the advantages it has over other machine learning solutions?
Windows ML in particular was built for to allow a developer to be able to execute those machine learning models on the user device. And the reason why that situation is important is because it enables you to light up scenarios where, for instance, the latency in order to get the prediction out of the model needs to be super small. Or in scenarios where you don't have connection to the internet or your connection is intermittent. So in those cases, it's super hard for the developer to host that model on the cloud just to run the predictions out of it. So it's better in that case to just bring the model down to the user device and execute those predictions locally.
Awesome. So the latency allows the developer to avoid the round-trip time associated with sending data to the cloud and getting the predictions back. And then it's also great when you don't have a consistent connection to the internet and maybe you're only occasionally connected when you need to retrain the model or download it so that you can evaluate it locally. And then
Exactly.
Windows machine learning, am I correct that it also allows you to spend cost only on evaluating the model and not for the evaluations that are done locally?
So yes, so think of it as a new tool in the toolbox for a developer. So as a developer, I can now spend my resources on training my model on the cloud, and then I can just evaluate that model locally, and then I have a cost reduction associated with that. So I can focus the resources that I have on the training part, for which usually I want to leverage the power of the cloud for that.
Awesome. So it sounds like Windows machine learning is a complementary solution to the other things that Microsoft also offers.
Absolutely. It was built to be a complementary solution.
So that's how that fits in the ecosystem. So when we're evaluating models with Windows machine learning, what kind of models do we use to evaluate, and then where can we get these models?
So you need to start with an ONNX model. ONNX is this new open source format for expressing machine learning models. And you can find pre-trained ONNX models already on the web. There is the ONNX Model Zoo. The Azure AI Gallery already contains ONNX models as well. Or if you already have your machine learning model trained in some other source framework, you can use converter tools to actually convert those models to the ONNX format.
Sounds like there's a lot of great ways to go ahead and convert or just obtain an ONNX model for local evaluation. So Roseanne, can you talk about how do the APIs utilize hardware and how do they make the most out of Windows 10 machines?
Sure. So Windows ML was built in order to provide you a nice layer of abstraction on top of your hardware. So it leverages all the hardware that is where Windows 10 can run from desktop to server machines. And it provides great flexibility to the developer where you can choose whether you want to have your machine learning model executed on the CPU versus the GPU of the device. So you as a developer can choose that.
So Roseanne, does this mean I can run multiple models at the same time on my machine, like distinct models?
You can even run them chained together to get the most out of the GPU.
That's pretty cool. So Windows Machine Learning is now available with this next release of Windows 10. So Roseanne, can you talk about some of the cool new features you're excited about with Windows Machine Learning?
So with the new release, we are excited that we have introduced the ability for the developer to execute these models in float point 16, which makes it more performant as well as reduces the file size on disk. So when you deploy your app, you don't have a huge model sitting on disk. Also, we have enabled the feature that is called custom operators for you to overcome like issues when your model has operators that are not defined in ONNX yet. And we have been working very closely with the IHV partners to really get the most out of their specific GPUs and CPUs. So all of that is already available for the developers starting with this release.
That's amazing. So with this new Windows update, how can I get started with Windows Machine Learning?
Well, super easy. You just need the latest version of Windows 10, and you need the Windows SDK. And really, that's all the tools that you need.
So it's just an include statement at the top of my project, and then I can go ahead and access these APIs?
Yes, the API is part of the Windows SDK as any other Windows API. All the inference engine for running these machine learning models are inside the operational system already, so you don't have to worry about bringing other DLLs. Everything is there. You just make API calls.
That's amazing. So we've had a great conversation about an overview of what is Windows Machine Learning. Thank you so much, Roseanne, for joining us. And we would both be really excited if you visit aka.ms/overview of WinML to learn more about Windows Machine Learning and access the source code available on GitHub as well as sample projects, and just learn more about it through tutorials and other documentation. So thank you again, Roseanne, for joining us, and we'll see you next time when we talk more about the cool things available with Windows Machine Learning.